Today I wanted to present step-by-step process of creating primary and standby Postgres database servers. That standby server will be kept up to date by reading a stream of write-ahead log records, or WAL files in short. That means if primary server goes down, or if anything else happens to it, we can just quickly elect that standby server to become our new primary server. And that's what we will set first then. But once we have that, we will add PG Backrest, which is a backup and restore solution for Postgres. And that PG Backrest will keep sending our WAL files and main backups to remote location. It can be any remote location of our choice. But what that means, that if even both servers, both primary and secondary server, go down, we will still be able to rebuild them and restore all the data from that remote location. And today we will build all of that, we will configure everything, and we will then perform the failover and various other disaster recovery scenarios. What that means? That means probably that video will be a bit longer than usual, but at the end of it you will have complete production-like environment. And just a note, in this video I will install Postgres 16 on Ubuntu 24.04 LTS servers, but that shouldn't matter because the process is similar for most Linux distributions. And installation and configuration process for Postgres also will be very similar for all Postgres versions that were released in the last few years. So you can follow this tutorial even if you have, let's say, Fedora and want to install Postgres 14 or Postgres 17. Postgres 17 is now available only as a beta, so that's why I'm showing process for Postgres 16 rather than 17. I am going to use AWS S3 bucket as remote location storage, but PG Backrest allows you to store WALs and backups nearly anywhere you want. So it can be another server, can be some, I don't know, NAS storage, or can be other cloud location like GCP or Azure. Can probably be something I'm not even aware of, but PG Backrest is very flexible and it's pretty easy to configure as well. That's why it's very common to see it in production environments. Let's get started then. My servers are going to be virtual servers in AWS, and they are called EC2s there. But again, it does not matter where your servers are located. If they are in the cloud or if they are on-prem, as long as you can configure them so they are able to talk to each other, you are fine. So I will just launch instances. We'll quickly create servers like, let's call it PG. And as I said, it's gonna be Ubuntu 24.04. For instance type, let's choose something from T3, maybe T3 large. This is the size of our server. So keeper, I will add SSH key. And network settings, I want to change here one thing actually. First of all, you might see auto-assign public IP. In production, definitely you don't want to have public IP on your database. But here, because I don't have NAT gateway, it's called NAT gateway, my instances otherwise won't be able to connect to the internet. And I don't want to create those NAT gateways, so let's just remember that these servers shouldn't really have public IPs. I should disable it. But for these purposes it's just for testing, so it's okay for me to leave them as they are. Because we will need simply to install some stuff. Let's go further. Security group, I can call it Postgres. And basically what I need, the SSH is already allowed. But I want to add one rule. We need to add port 5432 to be also allowed. So these servers have to be able to communicate on port 5432 basically. And as source, I want to choose my entire subnet, 172.3.1.16. And it will be our Postgres connectivity. Because your servers need to be able to talk on that port. Regarding storage, we can bump it a little bit, that doesn't really matter. What matters though in AWS, that I have to enable encryption. And that's it. And then I need two instances, actually, not one. We will just launch instances. That's it, two instances created. Let's view them. We can see they are pending. You can ignore that previous one. I realized I have got the instance running. Let's maybe change their names. This will be our PG primary. And this will be PG secondary. We should be able to connect to them shortly, initializing, but maybe already we can try. I will make the terminal a bit wider, open tmux, Now Ctrl B and then quickly Shift +5. We can divide the tmux vertically and we will log on to both of our servers. I think I have to log on as Ubuntu user. Yes. And let's change the host names as well, just to make it perfectly clear where we are. So sudo hostnamectl set hostname pg primary. And the same for secondary. We need to reboot them after that. Okay, but now when we log back on, that name should be then reflected. Alright, now what we can do, we can click Ctrl+B and then colon and type setw synchronize panes. This way we can type the same commands in both windows at the same time. Let's start with sudo apt get update. It's always first command you should run anyways. Let's clear again. Let me make it full screen. I believe we now know what we are talking about. Second command, not entirely sure if I need it, but I usually install GNU PG2 and wget tools. So it's sudo apt install GNU PG2 and wget. Perfect. Let's clear again. And now we need just one command to install Postgres on Ubuntu server. And guess what it is? It's PostgreSQL. Sudo apt install PostgreSQL. That's it. Let's clear again. We can check if it's been installed using systemctl command. systemctl-l pipe and we'll grep for post. We can see Postgres 16 main service is running. We can check exactly this service by typing systemctl status PostgreSQL at 16-main. PostgreSQL, sorry. And it is up and running. If we Ctrl-C that, maybe clear again. If we want to connect to the Postgres itself, we can use PSQL utility. That is something that is installed together with the Postgres, and you can use it. And then use user Postgres. We have the error. It says peer authentication failed for user Postgres. So you can see that we have to configure some bits and bobs. Let's stop this Postgres first. We don't need it up and running right now. We can use this command, but change status to stop. Oh, sorry. Let's switch the user to the root user. So now we can run this command again. Now if we check the status, we can see it stopped. What we have to do, we have to go to the data folder for Postgres. That's basically where the database files exist if you write something to that database. And this data will be kept in var lib PostgreSQL 16/main. If we run lsla, all those files and folders belong to Postgres user and group. So as I said, this is the location where the data of that database itself are located. But there is yet another location, and it's in etc. It's etc PostgreSQL /16/main. And here, it's the location where all the configuration files are being kept. Two very important files are here. It's pghba and postgresql.conf. And we will play with both of them, so you will know what they are for exactly. Well, let's actually modify that pghba, because we need to change some things here. So I do vim pghba.conf. You can use Ctrl F to go forward. And you can see some entries here at the bottom. Let's make it slightly smaller so they fit one line. Okay, let's close it. I hope this formatting is a little bit better. So let's change some things here. I will press I, and here in this first line, I will want to change that last peer to trust. Then entry for the Unix domain, also from peer to trust, and maybe this third one for localhost. Let's change this one as well to trust. Okay, we can now press escape, :WQ. Let's start the Postgres again. If I try to connect to that Postgres database locally now, I should be allowed in. And I am in. So I can do stuff like create database, Marek, let's say, and semicolon. If I press now \L, it should be displayed. Again, formatting not perfect, but you can see database Marek exists. So we now know that Postgres is up and running. Let's quit that, \Q, and let's press Ctrl B again, and colon, set W synchronize panes. It will unset it for us actually. Because what I wanted to show, let's connect again, user Postgres. If I create another database, let's say Jack, it will be only on that secondary, because these databases now are two separate servers. They don't talk to each other. So \L shows me Jack and Marek, that's on secondary. But if I do the same on primary, we can only see database Marek. There is no database Jack. What we want to achieve though is the first one, this PG primary, we want to have it as primary database. And when we write a data to this primary database, we want it automatically stream that data to secondary database, to this one. So they are both in sync. Whatever we write on primary, it's automatically replicated to secondary. And if anything happens ever to that primary database, then we can simply shut it down and elect that secondary database as our new primary. Let's do it then. And we can stop the Postgres service on both of those servers again. And what we want to do is to amend that pghba.conf file again, but this time on primary server we will allow connections from secondary. So let's just concentrate on that server, on the primary one. We have to play with this file again. Let's vim GHBA, and let's add, maybe at the very bottom, new entry. We need entry saying host, then replication. Then we need to specify a user that we are going to use for that replication process, and I will just use Postgres for that, Postgres user, and then the IP address of the other server, where the request for replication will be coming from, and it will be our secondary server. So let's check that IP address. This is its IP address, so 172.313017. We need exact address, so it's /32. I mean, we don't need, but let's be specific. And then trust. That means this secondary server will be able to connect to the primary for the replication purposes as user Postgres, and it will not require any authentication to do so. So escape, :WQ. Let's cut that PGHBA again. So that's our entry. And it's entry that this secondary server will be able to use to connect to primary. By the way, you don't need to change anything on secondary, because secondary is the server where the request will be coming from, and that automatically will be allowed on that secondary server. You only need to allow connections in on the primary. Perfect. Here in that folder though, there is one more file, and it's called postgresql.conf. And at this stage, I want to change one value in that postgres.conf, and I will tell you why. Let's first vim to that postgresql.conf, and use Ctrl F, and this is the value I want to change. Listen address currently is commented out, which means it uses default option. You can even see it here, defaults to localhost, but we want to change it to asterisk. And what it is, one sec, let me change it first, and then I will tell you what it is. The explanation is right here, to be honest. It says what IP addresses to listen on. That means, by default, this Postgres wouldn't listen on any external IP addresses or interfaces that this server is configured with. What I mean by that, let's maybe go to primary for a moment. For example, these are the IP addresses the primary server is configured with. It has a loopback interface 127001 and it has ENS5 interface configured with this IP address. And by default, Postgres will only listen on loopback LO interface 1 and not on that ENS5 external interface. That means these two servers wouldn't be able to contact each other, because they are going to communicate on this interface. That's why we have to change this listen address to all possible interfaces that Postgres has. You don't have to listen on all interfaces. You can be more specific and choose just one or two, let's say, but usually people tend to use, just like me, just use asterisk. That means every single interface that is configured on this server, the Postgres will be listening on. Okay, let's save it. Escape, :WQ. And we have to do the same on the primary. Alright, what we can do now, we can start the Postgres service again on primary server, because primary basically is now configured. We can check the status as well. We can see it's active and running. On secondary, if we didn't change anything, the Postgres should be down. And it is, inactive dead, okay. And that's fine. If for some reason you have it running, you have to stop it right now, because we are going to configure it as our secondary server. So we go to the location where Postgres keeps its data, and that was in var lib postgresql /16/main. This is all the data, and we want to remove it all. But be careful, because remember, all the data is gone at this stage. Our database, did we call it Jack or something? That will be gone, and anything else that is saved now will be gone. We are removing it all. Alright, as you can see, nothing there anymore. What we want to do now is we will run a command called pg-base backup. And if you want to learn more about pg-base backup, even directly on the server, you can run man pg-base backup. And as you can see, it says take a base backup of PostgreSQL cluster. And there is quite a long read with all the properties and commands and arguments, but I will just talk you through the ones that we are interested in. So first of all, you have to run it as user Postgres. That's very important. So if you are as somebody else, you have to make sure that you run like sudo u Postgres. Sorry, it's small u actually. I mean, I don't need sudo here because I'm already root, but never mind, it doesn't matter. The important thing is to run it as user Postgres. Next thing is the command itself, so it's pg-base backup. Then it's -h and the host, the remote host, so who we want to replicate from. And we want to replicate from our primary. And that's its IP address. So that's where we want to replicate from. So it's 172.3131144. Next, we can do -w, lowercase. That means we can do it without providing any credentials. And it's up to you if you want to use credentials or no. But, you know, I'm lazy. We configured in PGHBA on primary already that we trust that other server, so we can do that conversation without any additional passwords. Now, -U, and we want to specify the user that will be used for the replication purposes. And I used in PGHBA here on the primary, I used user Postgres. But you can use different user here. For example, you might have dedicated user like a, I don't know, replicator, whatever. You can call it whatever you want. But whatever you use here, you have to specify it in PGHBA on the primary server. But for me, it was the same user, and it was the same user as here, which was Postgres, created by default when we installed PostgreSQL. Now, there are some other options like -F. This is the format of the output. We can choose plain, for example, but plain is used by default anyways. In theory you can omit it, but I like to include it in case one day somebody decides it should be not the default one anymore. Next you can specify the stream method here, and it's -X. And the mode I always use is stream. And you can either fetch or stream here. It's the information how you want to fetch WAL files, the write-ahead log files. If you're not that familiar with Postgres, basically whatever you do on Postgres, like we created the database, all that information is first written to a file called write-ahead log, or WAL in short. And only then, once that WAL file gets that information, it is then, and only then, written to actual database. This is to make the database even more resilient. The thing is, when you have very large database to replicate, this process of taking PGBase backup, as we do now, might take hours and hours or even days. And remember that the primary server is still running and probably keeps receiving new information. And that information is written to that WAL files, and we choose here if we want to stream all those new WAL files to this backup server as soon as they are created, or if we chose fetch method here, then those WAL files will only be fetched at the very end of the process, not real time. So the stream method creates separate channel that listens real time if there are any new WAL files created on primary. And if WAL files were created in the meantime on primary, it will get them not waiting for the PGBase backup process to complete. It will fetch those WAL files immediately, will grab them from primary and save them on secondary as kind of independent process. And then we have -r, capital R, that tells the Postgres to create recovery conf and standby signal file, so that server knows once we start the Postgres, this server will realize it is standby server and it is not supposed to write anything to the database. It is only supposed to keep replicating data from primary server, so it's not supposed to write anything itself. You should not be able to create or change any data on this server. And that's exactly what we want at this stage. This is supposed to be only secondary, listening to primary. Next thing is your choice again. It's -S, and I will call it a Marek slot or something like that, and -C. What it is, well, these two arguments go together. -C says to create slot, and -S is the slot name, and I called it Marek slot. And they both combined create what's called replication slot. And it's not mandatory, and to be honest, I'm not sure if I want to talk about it, because that's basically subject for entire different video. So maybe let's just say you're not forced to use it. That means, basically, maybe I will tell you something. That basically means that all the WAL files that are on primary, the primary will wait until secondary confirms, yes, I've got all the WAL files, will confirm it back to primary, and only then the primary will get rid of any WAL files. It can actually cause some problems, because if your secondary is down, the replication slot is written on primary, which means the primary will keep accumulating WAL files. And you might basically fill up your volume, but it has also great advantages. So, okay, well, let's leave it as it is, because we just need one more argument, and it's -D, capital D. It's a directory where we want to write all those data that we fetch from primary, where we want to save it on the secondary. And we want to save it exactly where we removed all the previous files. And it's this location. Alright, let's press enter then. That's it. Well, this database is very, very small on primary, so it took only 2 seconds. But as I said, this process as well can take days. Now the last thing we have to do is to start Postgres database. Now let's do a little experiment. Let's go to primary, connect to database. We now have Marek and Postgres. One second. That's better. So we've got Marek, we've got Postgres, and template 0, template 1. If we now create new database, like here we've got Marek 1, 2, 3, 4, 5. We go now to secondary and connect to database. You can see this data is immediately replicated. So that means any data here, any new data, is reflected on backup server as quickly as the transfer between servers allow to replicate that new information. And if you run on the primary server, select asterisk from PG replication slots, you will see that Marek slot was created, and it's actually used to stream that data immediately to secondary. Let's try to write something on secondary though. Let's say I want to create new database here. And you can see you will not be able to, because this database is currently in read-only mode. We will later on simulate the failure of primary, and we will elect this standby server as our new primary, but before we do that, let's add yet another resiliency feature, which is external, or let's call it offsite backup. And we will install a tool called PG Backrest, and we will use it to send the main backups, and we will also start archiving all the write-ahead log files that are being generated, and we will send all that information to that offsite storage. This way, even if both servers go down, both primary and secondary, we will still be able to rebuild it using that offsite backup. And as I said before, I will use AWS S3 bucket as remote location, but you can configure other remote locations as well, whatever you have there. PG Backrest most probably supports it. What we need to do first, we have to create SSH connectivity between the servers, because PG Backrest will need to have full information about both servers, primary and secondary, and it uses the SSH connection to do that. PG Backrest does not use separate user, it will use the Postgres user that was already created when we installed PostgreSQL. So, as you can see, I exited Tmux for now, because I don't like how Tmux sometimes plays up when copy-pasting between them, and we will do some copy-pasting. And plus there are various ways of creating and exchanging SSH keys, but never mind. Basically what we need as a user Postgres though, so sudo su-postgres on both of them, and we just create SSH keys, and the command is ssh-keygen. Then just enter, enter, enter. Okay, do the same on primary. Alright, now if we do lsla, we can see new folder .ssh, the same here, was created. So let's clear again. And if we go there, we can see a pair of keys. This is private key and this is public key. And basically we have to copy what's inside here to a file called authorized keys on that server and the vice versa. So we will copy this public key back to this server, so they will trust each other. So we are in .ssh, we touch authorized keys. That's the file we need, so we can do vim as well, because we need to add public key from here. This is the public key, I will copy that and paste it there. And now here on this server, we copy from here. That's all we need really. Now, what's the IP address again? That SSH 172.313.1.144. Yes. Alright, you can see now it says PG primary. We SSH'd from secondary to primary server. So if I exit, we are back on secondary now. But let's try the other way around. One second, what's this address? It's this one. So let's try both sides. SSH 172.313.0.1.7. Yes. Oh. Yes, okay, secondary. So we SSH'd from primary to secondary. So we can exit. We are back on primary. That works. That's fine. Now we have to install PG Backrest, and the command is apt install PG Backrest. I mean, let's exit. Oh, I mean, we need actually root or sudo. Yes, let's do it in the meantime here. That's it. If we now go to etc location, well, you can see there is a file called PG Backrest. So that's the new file, and the owner is Postgres. And the same here. One second, what's going on? I was doing something stupid, I think. But never mind. What I mean, this is the file we are interested in, and we have to modify that file, because this is basically the main configuration for pg-backrest tool. If we cut that file, we will see that there is some basic config, but it's just a template for you to change. This config will not work for you as it is now. So if you go to official pg-backrest website, like have the user guide, and there is loads and loads of info, and I will skip this part, just wanted to know. It's really well written, and it says about WAL files, encryption. But what I'm interested in is S3 compatible object store support. But you can find here Azure, you can use SFTP, you can basically use storage in any remote location you want. But I chose S3 bucket for that purpose. So let's go to AWS. Do I have any S3 buckets here in this account? Oh, there is one. I don't even know what it is. Never mind. Maybe let's create new bucket. Let's call it what? pg-backrest automation. Oh, autumn oven, something like that. All right, and just create bucket. Oh, not underscore but dash. Okay. That's better. But also important is the location, the region, AWS region, EU West 2, if you use S3 bucket as your backup solution. We need that EU West 2 as well, we have to remember that. So let's go back to the servers. And whatever is here, we are not interested in, because you can see it's even for different Postgres version. I have the config ready for us, so let me just paste it, and I will just quickly go through what it is about. Let me just pick IP addresses again. And now just vim pg-backrest d9d, we just remove everything. For primary config, maybe let me leave it as it is, or go to secondary, do the same. But the config will be slightly different for secondary and for primary. So this, or maybe let's do it on primary. This will be the name of the folder in our S3 bucket. This is how pg-backrest will send that data to S3. Retention full, it means it will keep 2 full backups in the S3, and it will automatically get rid of the oldest one once it receives new one. The bucket we created was that, pg-backrest autumn oven, and this is the endpoint, so this is the important bit. You have to remember where you created your S3 bucket, because you have to use that information here. And then we just some info, like we want to compress it. It's always better to compress because it will use less bandwidth and also less space on the S3. And this is the information backup standby. It's optional, but basically we run the command, you will see shortly. We run the command on primary, but the backup will be actually performed by secondary. That is useful because your primary server is usually the busier one, so it's good to offload some work to standby. And this is the user we want to specify. This is the IP address of secondary, and on secondary there is an IP address of primary. So we can see the difference: pg2 host, pg2 being the secondary, and pg1 host we pointed to primary. They have to be able to talk with each other using that SSH connection. And the location on each server where the data directory actually exists. But it's the same on both. And this is for WAL archiving, that we want to compress that data as well. Alright, let's save it then. And here as well. There is one thing though, we have to change in postgresql.conf file as well. So let's go to etc postgresql 16 main postgresql.conf. We scroll down. to this section, archiving, and we want to uncomment archive mode. Archive mode will be on. This is for wall archiving, means write-ahead logs. It's the information that whatever is written to the server, we also want to have it in our archive. And Postgres needs to know what command is used to actually archive those wall files. You can see below here, archive command. You can also find this information in pg-backrest instructions. But what it is basically pg-backrest -- stanza equals main, archive push %p. Well, I mean, if stanza equals main, that depends on you, because we will create something called stanza, and we will call it main. But if you call your stanza a different way, then you will have to reflect that in this configuration. That stanza is not created yet, so I know it might be confusing. And %p, that's the path of the file to the archive. This is determined by the pg-backrest itself. This is kind of like parameter to not repeat information already in pg-backrest.conf. Alright, but we have to do the same on secondary. Now we can save them both. Let's restart the Postgres as well after all those modifications. Okay, let's see the status. I nearly forgot a very important bit, because we have to make sure, I can't remember if I changed the IAM rule, we have to make sure that our instance, or server, let's say, is actually able to write to the S3 bucket. So this is the primary, and I forgot to add IAM rule. Okay, one sec. So I've got a role, it's called role. So the server is able to connect to S3 bucket, and that's very important because that's what we need. Because that's where it is going to send the backups. Okay, that's better. Fine, that's perfect. We now should be able to create that stanza. This is the main thing that pg-backrest uses for the backup purposes. It simply synchronizes like all the information it has for both of the servers. I need the user to be Postgres though, and the command is pg-backrest -- stanza, and then, that's what I said, we're going to call it main. In all the documentation in pg-backrest they always say main, but you can call it whatever you want. And then stanza create. Maybe I will add log level as well here, maybe. So we will see on the console what's going on in the background. Let's press enter. As you can see, it reads the S3 bucket information. It can see the folder in the S3 will be called cluster1, and we can see it completed successfully, and it took just 3 seconds. So if we go to S3 bucket now, use this one, we can see now new folder created called cluster1. And if we click on that, we can see 2 more folders. Archive, which is going to be used for wall archiving, write-ahead logs, and the backup, which is going to be used for full Postgres backups. But please note though, the full backup is not taken automatically. It's up to you when it's taken, and let's just do that. Currently, let's have a look first inside. We have main, and we have those 2 files, but it's 370 bytes. This is not the backup. So let's go back. Let's go to the servers. And now, to take the backup, the command is pg-backrest -- stanza equals main again. You always have to specify which stanza you want to use. Let's set the log level to console, and maybe detail. It's detailed information. And then type equals full backup. I think it's without dash. First backup, you should always do full backup, because pg-backrest can do also incremental and other types of backups, but you need the full backup first, because currently we don't have any. So if we now press enter, full backup is being taken and it's being sent to S3 bucket. Alright, nice. What we can do now is type pg-backrest info, and you get the information what is the database backup size. That's the size in S3. Sorry, no, this is the real data here on the server, and the backup size is actually much smaller because we are compressing it, remember? And this is regarding the WAL files, write-ahead log files. Each backup will have some WAL files that are kind of bound to this backup. And then when pg-backrest removes that backup, if for example you send third backup and it only is supposed to retain 2 backups, it will also automatically remove the corresponding WAL files. So it keeps everything all nice and clean for us, and we don't have to worry about it. Let's just go back to buckets, now backups, main, and we can see more files and we can see new folder. If we go to that folder, you can see that bundle, this is the actual information, and some PG data. And it's all compressed exactly as we have it configured. And that's basically it for the configuration. I mean, we've got 2 servers. The primary sends all the data to secondary, and regarding the pg-backrest, we can simply run like cron jobs or however you want to run them. You can create a cron job that will run this command and take the backup, let's say once a day or once a week, maybe on Sunday, it's up to you. But oh, there is one more command, sorry, I wanted to show. pg-backrest stanza main check. That will show you the information about the stanza itself, and life is good. We can take another backup if we want. Full backup, let's say. Let's send another one. So, if I run the pg-backrest info now, we can see now we have even 2 backups in the S3 in the cloud. Let's start breaking things then. That's what the resiliency is for. We should be able to recover from various scenarios. Let's maybe make a big mess by physically removing the entire running primary Postgres server. Let's just go to the AWS, to the EC2. Let's just terminate that running PG primary. Instance state terminate. Let's make havoc. The connection should be gone already. Yes, we can see, closed by remote host. But we still have secondary. And this is actually very easy to recover from. Because our secondary server has all the information that we need, we only have to remove that read-only behavior. Remember, it can't write anything. It can only read. We have to promote it then from secondary to become primary. And it's super easy. You just connect to the Postgres and you run select pg promote. It's actually underscore and brackets at the end because it's function. Press enter, that's it. It says true. From now on, I am able to write to this server. Let's see. We've got Marek and Marek 12345. As you can see, now we can write to it fine. So what you have to do, you have to simply point your DNS to the IP address of this server now, and you can carry on as if nothing had happened. You will obviously need to build new standby server and create replication, this time from this server. This is our new primary now. But this is something you can do later on. From customer perspective, all services are now back up and running. I mean, once you point the DNS to this server. That's fine, but let's maybe break it even further, yes? What if we have a failure of this secondary server? Maybe, what can we do it? Maybe let's say somebody wiped out all our data. Or maybe the data was corrupted. Yes, let's do that. Let's stop the Postgres. Let's go to the main database data folder. Yes. All those files are Postgres itself, data files, so let's remove them. All our data is now gone. As you can see, it's empty folder. To recover from S3 though, let's close this. That server is already gone. Is it? Yeah, terminated. Before we recover from S3, let's open the pg-backrest.conf file. Currently, we have information about other server, but that server is gone. We have to treat our server, this server, as the primary one now. So let's just get rid of any line that talks about pg2. and write that config. And now, again as Postgres user, so you can run basically also from any user that has the sudo privileges, and it's pg backrest, again stanza is main for us, restore, enter, and as you can see, already grabbing the files from S3, and because it's not a lot of data, it completed successfully in not even 5 seconds. What does it mean? It means if I do ll now, can you see my silly mistake? Everywhere in the config I had Postgres 15, not Postgres 16. So technically, we could recover from that, pointing to a different folder. But to do it properly, let's clear that. No, let me do one more thing. cd, somewhere here. Yes, now we have 15 and 16. First, let's remove that entire 15 folder, we don't need it. And now let's amend our pg backrest config. That should be 16 from the very beginning. Let's run that command again, restore, another 5 seconds or so, but we can see now, at least it's going to right folder. Awesome, now we can start the Postgres again, and hopefully it will, okay, I believe it's fine. It's running, but let's log on. Let's see what's inside. The Postgres, the pg backrest, works as expected, as we can see. So, okay, that's all for today. So I hope you liked it and thank you for watching.